Use an exponential model to predict values and applications. We're just going to jump right in. Deer in a local forest have a population of 70 with a yearly growth of 6%. Use the following model to predict the population of deer after 10 years. The model is A equals 70 times 1.06 raised to the t. Now, just to refresh, this is our initial value. This here is our growth factor. T stands for time period, and this is our ending amount. All right, so that kind of gives you the idea of what all these pieces are. Okay, so let's go ahead and figure out what we have. Now, we know we are talking about after 10 years, and we have a yearly growth. That means T is representing years, and therefore T is 10. I point this out because sometimes your time period is 6 months or 4-month chunks. So you have to make sure you understand your time period so you know how to correctly put in your number. So in this case, T is 10. So A equals 70 times 1.06 raised to the 10th power. Now when I raise, right, order of operations, I take 1.06 raised to the 10th, and I'm going to end up with 1.7908, and it keeps going. Now I recommend keeping that number, that full number, in your calculator. Then you just hit multiply, right, because this means multiply by 70. By doing that, you don't round, you keep your most accurate number, and you end up with 125.359, goes on and on and on. Now, with applications, it's very important to recognize what are we talking about. So here we are talking about the population of deer. Now, can you have a partial? No. Even if we have a 3-legged deer, that is still a whole deer, right? There is no way to have a partial deer. So this is the same as saying the population after 10 years would be 125 deer. It's just, that's the population. Let's do another. A new vehicle priced at $47,000 decreases in value approximately 12% per year. Per year. That means T is in years. Use the following model to predict the value of the vehicle after 5 years. So T equals 5. You'll notice the model is A equals 47,000, right? The initial amount, 0.88. 0.88. Because it's a 12%, that means our growth or our decay factor is found by taking 1 minus 0.12, which is 0.88, raised to the t power. All right, so time is 5. So we're going to take 5 and plug that in. So A equals 47,000 times 0.88 raised to the 5th power. Again, order of operations. So we do my parentheses raised to the 5th power. So I have 47,000 times the value of 0.5277, and this just keeps going on and on. Again, keep that value in your calculator and then hit multiply, right? Times by 47,000. So we get a value of 24,803.40009, and it goes on and on and on. Again, what are we talking about? So now we are talking about money. Well, money goes to the nearest penny, right? 2 decimal places of cents. So the 0 tells me to round down. So my final value, after 5 years, this car will be worth $24,803.40. And let's do one more. The population of fish started at 7,500, and after 1 year, there were 7,250. The decrease is exponential, so use the following model to predict the population of fish after 8 years. So to find the decay factor, we took the most recent. So they took 7,250 divided by 7,500, and that gave us the decay factor. Notice we're decreasing, so it's less than 1. After 1 year, so that means time is in years, and we're looking at time is 8. So 7,500 is the initial, times 0.967 raised to the 8th. I do my order of operations, so I'm at 7,500 times 0.76456, again, keep it in your calculator, times 7,500, and we get 5,734 and some change. We're talking about fish, so same thing, you can't have a partial, so 5,734 fish after 8 years.